So you guys are in the SWG intro session, so the storage working group under the CNCF. We've actually got a panel for you guys today. So I'm going to start with a little intro of what the SWG is all about, what we've been doing over the past year, some of the projects that we've been talking about, and a little bit of landscape. And then we'll do a panel that Ben's going to help us moderate. So first of all, the storage working group, it started about a year and a half ago or so in CNCF, and we were meeting bi-weekly. And so, if you get anything from this presentation, the takeaway is please join us. Please contribute. If you're interested in chatting about anything storage within the CNCF landscape, please come join our meeting. If you're interested in presenting anything storage, and you've got topics or projects that you may think are interesting to the community, then we'd love to hear about them within the working group. So this is the way that you engage us, whether it's through the GitHub repo or through our Google groups. Right, all these different ways are places that we're here, kind of listening and collaborating. We've got actually really good collaboration from some of the biggest names, or some of the names that a lot of you guys probably recognize within the storage industry. So whether it's Datera, Dell, Diamante, Docker, you guys can see the list there. There's about 30 companies that are collaborating together within this working group, and that have really generated, I think, the information and knowledge that I'm going to share with you guys today about storage. So why is storage critical? Right, hey, if we're talking about cloud native, the perspective, if you rewind the clock 4 years ago, was, hey, cloud native is just about stateless, right? It's about running microservices, right? It's about these new ways of running applications that tended to be stateless. And the reality is that there is state, right? If you're going to build an application, you're going to move it from a monolith to a microservice. There's a certain aspect of that application that stores data somewhere, right? So if you forget about that problem, right, you're just shifting the blame or shifting the problem to some other team. So at the end of the day, if you're going to rebuild your app, if you're going to focus on these cloud-native environments, you have to have a comprehensive lens to doing that. So you have to think about state. So the second point here is that there's tons of patterns within cloud-native, and portability is actually one of those patterns that we want to enable. So if you don't think about state, and you just rely on another team, then you can only move that application to wherever that team supports. So we want to think about portability as a key aspect, and we want to make sure that we enable applications. We enable them to run in any cloud that you want. And then the last point here is that in cloud native, interoperability is key. And if we have applications, we want to make sure that many of the applications become relevant to these cloud-native environments. So, the patterns of dynamically managing applications, we want to make sure that we can actually do that for all types of applications, not just the stateless ones. So, a few key points, and I think the biggest one here is we want to expand the relevance of all these key innovations that cloud-native is bringing to our applications, especially when it comes to persistent apps. So, the goal of storage within the CNCF. In order to drive the ubiquity of storage, ubiquity of cloud-native computing, the CNCF intends to enable a thriving storage ecosystem that is vendor and platform neutral and interoperable for applications. All right, so we want to make sure that all types of storage projects are thought about within the CNCF landscape, and we want to make sure that we essentially create a view of the world that incorporates all of them. So what is the mandate for the storage working group? The TOC within CNCF have given us these 3 key things that we're trying to focus on. The first of all is to create this common body of knowledge. So we want to clarify the terminology and the landscape of different components that make storage successful within cloud native. The second is that we want to compare the components and see how they're used in different cloud environments. So whether it's on-prem, off-prem, whether it's across different types of clouds, or whether it's just the key fundamental technology of, is it a key value store, is it a relational database? We want to define what all the types of storage are within this to be able to place them in the landscape. And then the last key point is that we want to compare and contrast the different properties of the storage. So in cloud native, there may be certain things that are more important, like what's the availability of my app, especially if I'm going to choose a cloud service to run my persistent application on top of. I probably want to know what the availability constraints are and what's going to be important for that application. So we want to compare and contrast the different technologies and then look at some of the properties across these technologies to figure out where are they in the cloud native ecosystem. And so those are the key things that you'll see the actual working group approaching moving forward. So projects. The other thing that we're doing in order to kind of like round out our view of storage in cloud native is that we're constantly reviewing and hearing from different projects from the community. So up here is a list of the projects that we've actually heard from in the past year. If we look at this list, CSI, that's a container storage interface. We heard from that earlier in the year, or last year. Rook, which is now a CNCF project presented to us, Rextray, TICV, PingCap, so all types of different projects. And if I just kind of like classify some of these real quick, you've got projects that are interfaces for interoperability, such as CSI. You've got projects that are storage platforms, and maybe that's database storage platforms, and that would be PingCap and TICV. You've got newer storage platforms for containers, such as .mesh and OpenEBS. And then you've got even Vitesse, which was discussed today within the keynote, which is like a sharding technology for a database technology, or for MySQL. So the projects all kind of range storage related that we've heard from this year. So storage is a kind of a critical resource when you break down the infrastructure components in these cloud native environments. On the left side, you can see that the storage really integrates directly and works with the orchestration and management components, but also with the layer below, like the runtime component. And then on the right side, there's a few key things that we think about with storage and cloud native. One is the volumes and drivers, local storage management, and remote storage access. These are all just critical components or critical pieces of storage and cloud native. Here's how we like to think about the different types of storage that we'll be discussing within the working group. If you go kind of north and south, you look at the way that people tend to think of volumes or our traditional POSIX-based storage, POSIX or LBA-based storage. And this is where a container is actually like reading and writing blocks down to files that are provided by way of a file system. Right, so the volume aspect of storage is one key thing to think about. If you go east and west, then we also have other types of storage, and that includes data services, so higher order data services like SQL, NoSQL, log streaming, right? Those are all also storage services as well that we care about. So whether it's east and west and using the networking stack to go out to another service that may be provided by a cloud, or maybe you're running yourself, or whether it's north and south, going down to disks and volumes and NFS shares, those are both like relevant targets as we talk about storage and cloud native. There's a few key patterns early on that we've identified within the storage working group that can help us understand different components. I think one of the most important patterns is interoperability. So we're not talking about like stacking data services, right? We're talking about just interoperating across data services in a lot of these aspects, or a lot of these components. And so the interfaces that are defined become really critical to make that happen. We want to make sure that the platforms in cloud native storage are self-service. So the expectation from a user experience perspective is that if you have someone who's going to consume an application, that they're able to define what type of storage that application needs, and that on the back end, as that storage platform is servicing the application, that it's able to provision and make that storage available. So self-service is a key pattern. I talked about interfaces a little bit with interoperability. The next one here is API frameworks and tools. So in terms of building the tool or the plugin that helps you interoperate with storage, sometimes frameworks can be helpful, and these frameworks can actually show up as tools. So we want to try to classify and understand the ecosystem with some of these key patterns. As we get to this next piece, we're talking about another pattern is whether the data service is something that I run myself. So that would be a external service that I'm running and managing, and hopefully using like an operator or a framework to actually help me manage. Or maybe it's an external service that a public cloud runs for me. So if I'm in Amazon, then maybe I'm using RDS for my SQL services. If I'm on-prem, then maybe I'm using Vitesse to run my MySQL services. Right? Just both types of patterns, whether you're operating yourself or you're using an external service, are both relevant. And then there's the storage access method. So how am I actually accessing the data? What's the protocol that I'm using to connect my application to the storage? This is one of the ways that we're looking at the landscape in terms of those different components or patterns. From the top, you've got your container orchestrator. The next level down is the interface between the CO and the storage system. So you can see that we've defined some of the key projects such as CSI, the Docker volume driver interface, the Flex volume interface, or a native interface. And here you can see on the bottom left side where the frameworks and tools come into play is, maybe I'm going to build this plugin myself to interface these two components, or maybe I'm going to use like a framework and a tool to help me interface these components together. What that all ends up building us is this. Like, if I can interoperate between a cluster orchestrator and a storage platform, then what I can actually do is connect my workloads directly to storage systems transparently. All right, so the landscape is kind of fulfilling what the vision or the user experience of cloud native should be, where a workload can request a storage volume or access to some type of storage, whether it's block, POSIX, SQL, NoSQL, et cetera, and the interoperability should make that workload connect to the storage system and transparently. So what are the next steps for the working group? We've done we've heard from lots of different projects relating to storage. I think we've all become a bit more educated on what this ecosystem looks like and what the landscape looks like. The next steps is that we're actually getting more direction from the CNCF TOC, and they've given us more guidance on what they actually want. And we're going to be working on a white paper and actually giving some deliverables back to the TOC. If you guys are interested in participating in the storage working group, whether you want to present projects, talk to us, just join us and collaborate, we'd love to have you. We actually have another session at the conference today, so not today, but tomorrow, there's going to be an advanced session for the SWG, and that's where we're going to have a roundtable talking about the next things that the SWG is going to be working on. So there's plenty of opportunities to join subgroups and talk about things that are storage related. There's also other sessions to hear from at the conference. So SOD's got a couple of intro sessions for Kubernetes and storage. I highly recommend you go check those out. Michelle also has a local storage session on Kubernetes. So this is about using local storage resources for your applications. That should be a great one as well. G is going to be talking about the container storage interface project. So one of the really critical projects we have in the Kubernetes ecosystem and the container ecosystem here. And then Jane's going to be talking about the snapshot support within Kubernetes. So other great storage sessions to see. With that, that's the kind of like intro to storage. We're going to kick it off and ask our panel members to come up, and Ben is going to help us moderate a few questions.
All right. Clint, is Quinton back? Or do we want to go and see if we can pull him from next door? And while Clint's doing that, we'll start off with, come on up, Steve. We'll start off with, let's do some quick intros. And let's also do something outside of storage that you'd love to talk to anybody about at the conference over the next couple of days. Okay, who wants to start?
Okay, I'm Steve Wong. I recently joined VMware, but I've been working prior to that with Dell Technologies and Dell EMC. I've been working on storage interfaces for Apache, Mesos, and Kubernetes for almost 3 years now, building in support to attach persistent volumes to support stateful apps. And prior to that, I've had a history on a bunch of other storage and backup products. The things outside storage are the thing that I'm really curious about. I'm going to cheat and say two things, but they're related. So IoT, I had a former startup called Wonderware that's big in that space for industrial control, SCADA. And I think there's real opportunities there to hook it up with machine learning. So those two things are not part of my job description now, but I'd love to talk to anybody about those.
Hello, I'm Ardalan Kangarlu. I work at NetApp. I've been working on Kubernetes for the past 2 years, and for the past year and a half, I've been working on Project Trident, which is NetApp's integration with Docker and Kubernetes. As far as my passions, I like traveling, and if you have any good tips about what to visit in Copenhagen, I'll be happy to hear. Thanks.
Hey everyone, my name is Saad. I am co-lead of Kubernetes Storage SIG, and I work at Google, primarily on the storage side of things for Kubernetes. Over the past year or so, my primary focus has been CSI. I've worked closely with G to co-author that. And outside of storage, at this conference, I am interested in learning about how we're going to continue to scale the Kubernetes community. We've got 4,000 attendees at KubeCon. So just seeing what we're going to do to grow to the next 4,000 is going to be a very interesting challenge.
Hi, I'm Quinton Hoole, currently with Huawei, previously Google, previously Amazon, and many things before that. My history with the project, some of you might have run across me in the very early days of AWS. I was one of the early architects and engineers on that project on EC2. Then I did a couple of startups, joined Google, eventually ended up on the Kubernetes project a few years back. I guess pioneered the multi-cluster federation side of the Kubernetes project. Some of you might have been at the CERN keynote this morning, which was pretty cool. I had a moment of proudness there, I got to confess. So yeah, and storage, I was involved in EBS in the early days at AWS. I also did a couple of storage systems after that in various startups. So I'm very interested in that space and trying to help out the working group here as best I can. Pretty late comer to the CNCF storage working group, but I'm hoping that I can ramp up in the coming weeks to be of some use there. Outside of storage, as I mentioned, federation is one of my things. I've also got this big passion at the moment about distributed operating systems. I think we need better ways to build distributed applications at the moment, which we have barely scratched the surface of. We've got bits and pieces of them, but we don't really have a coherent distributed operating system. And outside of technology entirely, I grow coral reefs in my lounge. And so anyone who's into coral reefs, fish nerds, coral nerds, I'm there.
Awesome. All right, great. And Quinton is actually going to be, I'm going to be handing the baton from Quinton as the TOC representative chair for the storage working group, and I'll be handing that baton to Quinton actually here. So Quinton, great to have you jump in for the storage working group. Okay, so the first question, I'm going to ask a couple, and then we'll open it up to questions from the audience. So the first one is CSI and the storage working group were kind of getting kicked off at the same time. So I wanted to ask Saad if you can chat a bit more about what CSI is and where you really see it going.
So CSI kind of got started around the same time as this group, completely independent of this group and independent of the Kubernetes storage SIG. It was a collaboration between multiple cluster orchestration systems, including Kubernetes, Mesos, Docker, Cloud Foundry. The purpose was we were all kind of facing the same set of challenges, which is coming up with a volume interface. Kubernetes had a very, very powerful volume plugin interface, but the problem was that adding new volumes to this interface is painful because you had to check code into Kubernetes. As developers of Kubernetes, we don't like this because it's difficult to maintain, difficult to test. Also, it requires that we give permissions for our Kubernetes components to these volume plugins, which is not something we necessarily want. Beyond that, developers of these storage plugins hate having to check code into Kubernetes to be able to add new volume plugins or fix bugs in their plugins. So ideally, we want something that is external. We could have gone at this completely on our own, but what we realized is the entire industry is facing this challenge. Other container orchestration systems and vendors would really like to be able to write just a single plugin that would work everywhere. So we decided we would collaborate and come up with something that would be beneficial to all of us, and that's where the CSI project was born. It was born as an independent project. Normally, projects are inducted into the CNCF. We haven't gone through that process yet. In order to go through that process, you have to show viability, show adoption, and various other things that probably Quinton can tell you more about. I think we're getting close to getting to the point where we can go ahead and start that process. We have some legal things that we need to sort out on our end first, and then hopefully we get that process started soon.
Awesome. Thanks, Sat. Next, I'm going to go, Steve, to you. This is really for anybody, but I thought I'd throw it to you, Steve, which is, now that we're starting to get some more experience with CSI, are there gaps that you're starting to see or anyone's starting to see? And how do you think would be the best way to fill those gaps?
Yeah, there definitely are gaps. Now, there are gaps in what's slated to be delivered in the early releases, but I think we've had vigorous discussions, roadmap discussions, so we're well aware that these have to be covered. And I think one of the big things is snapshot, which leads into using these snapshots to perform backups. You know, the whole goal of these external volume mounts is to support stateful apps. And stateful apps aren't new. What's new is running them in containers. And people have been using it in virtualization infrastructure and on bare metal for decades. When they do this, they're going to usually find that the keys to the kingdom are held in these stateful apps, and you can't afford for most of these applications to permanently lose this if there's a disaster. You know, anything from your data center burns down to human error is often a frequent cause, and there's call for, in normal business operations, for prudence to take a backup copy periodically and get it into a different failure domain, often in completely different geographic regions, and that's challenging. So what CSI is looking into is coming forward with a standardized interface to do a control plane on managing these snapshots, and you know, the underlying provider here often has different proprietary APIs and mechanisms and even capabilities there, but abstracted in a way that an orchestrator can hook up to it and use it agnostically, because the goal here is that you could take one of these volumes and maybe even make it portable across silos of Kubernetes, or take it from Mesos to Kubernetes, or even from legacy virtualization infrastructure into a container orchestrator scenario. All of those should be viable, and there are perfectly valid use cases for that. Going beyond backup, those snapshots potentially are useful for replication scenarios too, where these would be actually kept live at a DR site. Based on capabilities of underlying storage. And you know, I think that's where I see CSI going. And there's demand, there's plenty of users who are asking why they can't have it now. So, but I think it's better to get, you know, the first version out there in production quickly rather than wait for it. But there are already people looking at it.
So I completely agree with Steve's comments. Right now, the CSI interface is pretty basic. It just includes creating, deleting, attaching, detaching volumes, and there's ongoing work to support snapshots and hopefully in the future backup and other more complex workflows. But as far as some of the challenges that I see with CSI is that one is this might be from the point of vendors who are enabling CSI, is that the level of support from different orchestrators for storage and is somewhat different. For example, let's say if a node fails, what should happen, whether the plugin would take care of doing the cleanup, whether the node storage gets attached on a different node. Kubernetes has some mechanisms in this space, but that level of functionality and support is not uniform across all the different container orchestrators. And that may lead to more complications about the CSI plugins, whether they should maintain any state, whether they should handle complex workflows, which complicates the current design. So these are some of the things that I think the community should really looking to add more depth beyond just the API specification.
Okay, great. So moving past CSI, what are the other projects that you guys are seeing in the storage ecosystem right now that are making you really excited, that you're excited to either continue to see grow, or you yourself would want to be, if you had more than 24 hours in a day, be investing in?
Yeah, I think one of the interesting aspects of storage in a cloud-native context is that there are so many, I think I'm going to go out on a limb here and say, in a traditional, single machine kind of environment or server environment, there are a relatively limited number of storage types that are useful, and they cover a fairly broad spectrum of use cases. But as soon as you introduce this kind of distributed system, distributed storage, consistency becomes a problem, performance becomes a problem, durability becomes a problem. There are a whole bunch of new problems that kind of didn't exist to the same extent in a more traditional IT environment. And as a result, what I've seen anyway, we discovered pretty early on at Amazon, and Google's had exactly the same experience, so I think this is probably fairly universal, that you end up with a bunch of much more specialized kinds of storage, and often they're built in stacks. So you'll have consistent key value stores, and eventually consistent key value stores, and various different more specialized flavors of storage, and figuring out how all of these things fit together. And there's no strictly vertical stack of these things. In many cases, you have layers in the stack being excluded or replicated or whatever. So I think that's the most interesting area. And I guess of that spectrum of things, what I think is possibly one of the more interesting areas is very well-defined consistency and transaction semantics in particular storage systems. So Google has a project called Spanner, which was initiated many years ago, and which many of the systems run on there. And there's Cockroach DB and Titanium DB and numerous other very similar systems based typically on consensus-based record replication and transactions. I think that is an area that's likely to explode in the coming years, simply because there are tons of applications that actually need semantically sound consistency in transactions. And a lot of that is missing from many of the so-called NoSQL databases.
So I'm excited about changes in a number of areas. I think from a storage provider technology thing, things like persistent memory that fits maybe, it's memory that is persistent and can be treated like SSD, but has performance characteristics closer to DRAM, should enable some exciting new applications. Even connection technology like NVMe over Fabric has the potential to eliminate largely the tax for attaching external storage and separating it from your server. We're talking about potentially, I've seen articles claiming that you can expect sub 10 microsecond latency penalties for that storage being actually remote attachable. And those kinds of revolutions change things. I mean, I think back to, say, 2006 when Hadoop came out, and they challenged, for data analytics, this idea was that they needed to bring compute to the storage because of the penalty to try to separate it over the network. But some of those things that are the basis for things in widespread use have effectively been invalidated now by these technologies. And it takes a while for the software to catch up and take advantage of that. And I think there's some real opportunities in the whole streaming data analytics stack to take advantage of these, and they're going to revolutionize things. Container orchestration will be a part of that. Some of this revolution is already, I think, lagging. The things like the 12 factors were built to kick stateful out of your containers. But as we enable stateful running in containers with things like the orchestrators and CSI, you have to reevaluate some of those decisions to do things right. And people already, I think, there's a general consensus that monoliths in software are bad, that you need to break things up into microservices. But most people still have this old stodgy attitude that they're perfectly happy with running a monolithic database because they have the DBA who was the keeper of the kingdom, and they'll put many things in the same database server just because it's deemed as a resource that has to be managed by an expert. And the tables or the databases in that server are completely unrelated. But it creates these things where doing an update to that database takes forever. It starts to look like potentially draining the Atlantic Ocean into the Pacific. You've got 5 different users of this servers who all have to be contacted. Hey, can we afford to take this down this weekend to apply the security patch? To really take advantage of what things like CSI and running stateful and containers are, you have to change your attitude and take it to the next step to actually rethink some of those decisions that you made and have never questioned for a decade or more.
Awesome, thanks, Steve. So everything old is new again, and we'll just keep repeating these cycles, and maybe 8 years from now, we'll be rebringing compute back to storage because software will be fast again. Okay, so I think we got about 5 minutes. We'd love to open questions up to the audience. You were the first gentleman. Oh, here we go. Bringing the mic to you.
So you mentioned persistent memory, and I'm curious how persistent memory kind of plays into, like, as persistent memory becomes an actual thing, and later this year probably things start shipping and stuff like that. How does that change with regard to storage? I mean, obviously storage is going to be around for a long time, but as applications start moving towards persistent memory, that whole idea of distributing things, moving things out onto the network, again, I guess just like what you said, converges back the other way where you're now talking about needing to have local resources.
I think it creates a scenario where you really need things like abstraction layers like CSI, where you're not dependent and you isolate what the actual underlying technology is without requiring a total rewrite of an orchestrator or even a plugin. So step one is to enable the use of this kind of transparently. I think already many of the orchestrators have scheduling mechanisms like labeling, taints, whatever, so that they're flexible enough that regardless of whether you're bringing compute to the storage to the compute, in the case where the storage itself is containerized and potentially could move around, as I see it, those things are all potentially enabled. So this flexibility of a container orchestrator enables an app developer, and it's up to you if you're an app developer, and by app, I have a pretty broad sense where this could be full end-tier, big picture kind of stuff, that you want to gravitate towards platforms that will enable you to have all this flexibility without rewriting a bunch of stuff, and maybe even deal with this not with code but with configuration information. And
so I definitely would suggest going to Michelle's session to talk about local storage management too. Go ahead.
Just adding to that, so persistent memory has somewhat different qualities than traditional HDDs or SSDs, where they're accessed through the block interface. 4K blocks, these are byte addressable, so you need a different way of accessing your storage. However, a lot of problems that are present with current HDDs and SSDs, like for backup, are still going to be relevant for persistent memory. You still have to manage backup to a remote site, whether it's a remote node or somewhere else. You still have to manage snapshots of your persistent memory somehow. Also, one of the things that is important is also how to manage that in a distributed scale. How you can aggregate resources that are now distributed across the nodes and create a pool of persistent memory.
So we are out of time with that.
We are, okay.
I think.
All right.
Pretty sure it was 35-minute session.
I thought we had I think we have 1 more minute.
Oh, 30
Come
seconds.
on.
Well, we got one more question.
We got
Sorry.
one more question. I think you had the second hand up.
So Kubernetes is really exciting, and there's loads of opportunities and things like that. Is there a danger, and are we aware that there's a potential danger of trying to be everything to everybody? I mean, even just in the storage space, there is so much potential for all these different things that it does. And half of me is afraid that it gets so complex in the end that it makes maybe OpenStack look simple. And is there a danger in trying to be everything for everybody and covering every niche use case and things like that?
Who wants to take that? All right.
Yes, absolutely there is. We recognize that, and we've purposefully started with a smaller set of use cases. So for example, Ardalan pointed out, if you look at the CSI interface, it's very, very basic right now. And that was purposeful, primarily because the idea is to capture the bare essential necessity in the API that all storage systems are going to need, and then slowly expand beyond that. We're going to get to a point where there will be features that apply to a certain subset of storage that don't apply to other kinds of storage. What we've done so far is try and design the API in such a way that different types of storage can expose the full power of their, that's unique to their system without having to modify the interface. We do this on the Kubernetes side with things like storage classes and persistent volume claims. Within the CSI spec, you'll see that we have opaque parameters that we allow passing through to allow tweaking of knobs on the underlying storage system, so that the things that are captured within the interface are only the things that are absolutely essential for the full set. It is going to be a struggle moving forward to continue to make sure that we don't become a beast that is trying to be everything and good for no one. It'll be something that I'll keep a close eye on.
All right, so thank you very much to the panel for helping us out today. Good news for you guys is they're in our bi-weekly meetings. So if you guys have any questions, you want to chat more about anything storage related, come work with us, collaborate with us. We'd love to have you. And to close it out, I want to thank Ben for the leadership of the SWG, taking it from 2 to 50. Fantastic work, so we really appreciate the help. Thank you.